Good evening. Tonight's video will focus on operations in scientific notation. Our learning goal for this lesson is we will expand the properties of integer exponents to include comparing and computing numbers in scientific notation. For this first video, we are going to focus on writing numbers in scientific notation and multiplying and dividing numbers in scientific notation. We will begin with example 1. When we multiply numbers in scientific notation, we need to look at two pieces of information. The first piece of information that we need to look at is our coefficient. We have 2.6 and we have 3. These are our coefficients. In scientific notation, when we are multiplying, we are also going to multiply our coefficients. So we will begin by multiplying 2.6 times 3, which is going to give me 7 8/10. The second piece of information that we need to look at is our base and exponent. In this case, my base is 10, as it will always be in scientific notation. And then I have exponents 5 and 2. If we think back to our integer exponent properties that we learned at the very beginning of the year, we learned that when we have the same base, in this case 10, and we are multiplying, then we're going to add our exponents. Since we are writing this number in scientific notation, we are going to go ahead and keep our base of 10, and then we just add those exponents. 5 plus 2, which gives me 7. So I end up with a final answer of 7 8/10 times 10 to the 7th power. Let's look at another example. Again, we are doing multiplication. We are again going to focus first on looking at our coefficients, which are 3 2/10 and 4 3/10. So we will begin by multiplying 3.2 times 4.3. So I get 13 76/100. I'm going to go ahead and write in my times 10 because I know that I am in scientific notation. And when I work in scientific notation, I know that I always have a base of 10. Again, we can now look at our base and exponents. Again, calling back to those integer exponent properties, I know that I'm going to add my exponents when I have the same base and I am multiplying. In this case, I have -3 plus 5, which is going to give me +2. So at this point, I have 13 76/100 times 10 to the 2nd power. However, we must also remember that in scientific notation, to be in correct scientific notation, our coefficient must be greater than or equal to 1, check, but less than 10. In this case, our coefficient is not less than 10. When this happens, we're going to take a look at what's up here in the top left corner, LARS. LARS is a way to help us remember which way to move the decimal and how that's going to change my exponent. In order to make this number less than 10, I have to look and see, am I going to move my decimal to the right, which would give me 137, or to the left, which is going to give me 1.376. In this case, I will move my decimal one place to the left. LARS stands for left add, right subtract. In this case, I moved left 1, so I'm going to add 1 to my exponent, which is going to leave me with a final answer written in proper scientific notation of 1 0.376 times 10 to the third power. Now let's move on to division. When we divide numbers in scientific notation, we again start by looking at our coefficients. In this problem, my coefficients are 2.4 and 1.2. Just like with multiplication, we're going to go ahead and do the operation at hand. So I am going to go ahead and divide my coefficients. When I divide 2.4 divided by 1.2, I'm going to get 2, as 1.2 and another 1.2 will give me 2.4. Again, I'm going to go ahead and pull down my times 10 for my base of 10. And then I'm going to look over here at my exponents. If I think back to my integer exponent rules, I can remember that when we were dividing with numbers with the same base, we kept our base, in this case 10, and then we subtracted our exponents. So this time we're going to do 6 minus 3, which is going to give us a final exponent of 3. So I get 2 times 10 cubed. For our final example today, we will again look at a scenario when we end up with a number that is not in proper scientific notation. We will again begin by looking at our coefficients, 6 and 8. I should be able to see that right off the bat, I'm dividing a smaller number by a larger number, which I know is going to give me a fraction or decimal less than 1. In scientific notation, that number must be greater than or equal to 1. When I look at 6 divided by 8, I can look at this in a few different ways. I can go ahead and do the division, or I can think of it as a fraction, as that's what division is represented by. And I know that if I simplified 6 divided by 8, I would get 3/4. And I know that 3/4 is equivalent to 75/100. So my coefficient is 75/100. And then I'll go ahead and bring in my base of 10. Again, I'm going to take a look and see that I have the same base, 10, and I can go ahead and subtract my exponents, 7 minus 4, which gives me 3. Again, I cannot leave my answer this way because 75/100 is not in proper scientific notation. So again, we're going to take a look back up here to LARS. And remember that LARS stands for left, add, right, subtract. When I take a look at my decimal, I can see that this time if I move it to the left, I'm going to get an even smaller number. So this time I'm going to have to move my decimal to the right 1 place. And again, it's left, add, right, subtract. I moved right 1, therefore I must subtract 1. So I'm going to rewrite my answer as I move my decimal 1 place to the right to get 7 5/10 times 10 to the second power. If you have any questions or you need any additional practice, please visit iExcel and work on some of the scientific notation assignments. In my next video, we will tackle adding and subtracting numbers in scientific notation.